Hey guys, welcome to another USACO problem video, and today we're going to be doing the 2017 January Silver Problem Cow Dance Show. And as the title already states, the cows are going to be performing a dance show. They're going to be in cows and they're going to be performing it on a stage of size K. And we're also given the dance time for each cow. And whenever a cow is done dancing, they will get off the stage and the next cow will be able to fill in their spot. Our job here is to find the minimum stage which provides a total time that is less than the Tmax given. So to understand this problem a bit deeper, let's take a look at the sample input for this problem. So for our input, we have already drawn the n, the Tmax, and the cows. And our final answer is going to be k equals 4. And let's just simulate what happens when we have a stage size of 4. So I've already drawn this box around the first 4 cows. And just by looking at those first 4 cows, we can know that the first cow that is going to be that's going to stop dancing is going to be cow number 1 because it has the smallest dance time. So after 4 minutes, the first cow is going to stop dancing. So let's just write it as 0. And then after 4 minutes, the second cow will only have 3 minutes left to dance because 7 minus 4 is 3. And then the third cow would be 8 minus 4, which is 4, and 6 minus 4, which is 2. So this is what happens after 4 minutes. And then we also need to replace the cow that stopped dancing with the next cow in the array. So let's just do that. We got to replace this 4 as this. So we have 4, 3, 4, and 2 as our current stage. So we've recorded here that 4 minutes have already passed. And right now we can just perform the exact same thing to this array as well. So we're going to find the cow that stops dancing first. It would be this one because it has the lowest dance time currently. And that would be 2. So let's write 2 here. And after 2 minutes, this cow is going to have nothing. This one is going to have 2, 1, and this is going to be 2. So this cow has stopped dancing after 2 minutes. And we have a 0 here, so we need to replace something with it. And as you can see, we don't have any more cows in the array, so we don't have to replace anything. So we can just look at these 3 cows for now. And we can perform the exact same thing. So the smallest time would be 1, and then 1, we would just write it as 0, and we subtract 1 for both of these, so this will be 1. So we write 1 here. And then the lowest is 1 again, so we just subtract 1, and then it would be 0, 0, 0, and we write 1 here. So if we sum up all these values, we would have 6, 7, 8. So our t is going to be 8, 4. For k equals 4, we're going to have a t of 8. And as you can see, t of 8 is going to be less than or equal to the max t. So as you guys just saw there, given the value of k, we're able to find the total time that it takes the cows to dance. And all we need to do is compare that total time to the Tmax to see if that stage is available. But how do we do this if we don't know the actual value of k? Well, one way is to try all the possible values of k. And that would take n times because there are n possible values of k. For each k, we have to go through this process, which has a complexity of n squared. So we're going to multiply that by n squared. And this will give us n cubed. And because the n is 10,000, we're unable to do n cubed because that would exceed the time limit. So what do we do here? Well, we can make one observation. And the observation is that as k goes up, as k increases, we're going to have more chances of succeeding the t to be less than a t max. Because if you think about this, if we have a larger stage size, the cows are going to generally finish up faster, meaning it's going to give a smaller value for t, which means it's going to get closer and closer to being smaller than t max. So if we look at this situation, when k equals 1, it's obviously going to exceed it. If k equals 2, it's going to be exceeded. If k equals 3, it's going to be exceeded. And only when k equals 4, it's going to be good. And when k equals 5, it's also going to be good. So if we see something like this, it is an indication to use binary search. So say we have an array like this for all the possible values of k. So let's say we have a lot of x's, and then we start getting check marks, because that stage size would work. Okay. So all we need to do is we need to pick an item that is in the middle. Now let's say this one is around the middle, I think. And after we pick this, we're going to check if this works. So after using this algorithm to check if this k works, we see that it does work. So what would that mean is that would mean all of these values, all of these values over here, they're all going to be check marks. So then all we need to do is we're going to shrink our top into this. So we're going to ignore all of these values because we know they're check marks. So now our array is over here. We're going to do the same thing. We're going to pick the middle. Say this one is the middle. And we're going to check if this k works. Well, right now it doesn't work. So that means everything on the left is all going to not work. So we can just ignore all of these. And we can also ignore this because this one also doesn't work. Now we're left to 2. We can just check and either one. So if we check this, it doesn't work, we can ignore it. And we're just left with the check. More specifically, the first check that works. So to summarize, all we need to do is we're going to binary search the values of k. And for each of the values of k, we're going to pass it into a function that determines if it works. Let's take a look at the code for this problem. So in the code, I already have set up the function works, and it's going to take in a vector of cows and the int k. So this function is going to basically determine if a stage size of k is sufficient to get it under the t max. So I've just read in the values n and t. Now we're going to construct the cows. We're just going to see all of the cows into a vector. And this is basically the main part of my code. It's just going to be the simple binary search. As you can see, we first determine a low and a high. So that basically represents what portion of the vector we're looking at. And while the low is smaller than the high, we're going to get the middle point by doing this. And then we're going to check if the middle point is working for the vector cows. So we're going to use this function to check if it works. And if it works, we're just going to set the high to the middle because we know that everything above the middle is going to work as well. And then if it doesn't work, we're going to set the low to the middle plus 1 because we know middle and all of the values that are small in the middle would not work. Then we just output the low and we're done for this problem. Except we need to finish this function. So for this function, we're just going to set up the stage first. This is going to be the vector of the current stage, and we're gonna set a value of I to 0, and we're just gonna put the first few cows, the first k to be specific, into the stage vector. So now we're gonna simulate the actual dancing. So we're gonna keep track of the total, which is gonna be the final result. And we're also gonna keep track of a flag. And the flag just basically represents if we have ran out of cows or not. So if the flag is true, that means we have ran out of cows. And if the flag is false, then that means we have more cows. So I'm gonna say while the flag is not true, which means we still have cows. In the while loop, we're going to say the min distance to the maximum value, and then we're just going to get the min dance for each of the stage. So for each of the cows in the stage, we're going to get the cow that dances for the least time, because that's going to be the first cow that gets out. We're going to add the min dance to the total. Now we're going to cycle k again. And this time we're going to subtract everything by the min dance. And if something becomes 0, which means it has to be replaced, we're going to replace it. And we first have to check if we ran out of cows or not. So we can just say if I is not equals to n, so that means we haven't ran out of cows. We're just going to replace it with cow I. And then we're going to increment I. Or else we're going to set our flag to true. Notice how we don't break here, because if we break here, then we don't have everything subtracted by the min dance yet. So we need to wait until this loop is done, and then we break out of this while loop in the next turn. So after we break out, we still have a few cows in the stage. We just don't have any cows that can replace the cows that are already done dancing. So we're going to just set the remain to 0, and we're just going to, and the time it takes everyone to dance is just going to be the maximum of every cow on the stage currently. We're going to return the total plus the remain. We're going to see if it's less than t. So if it is less than the t, we're going to return true. If it is not, we're going to return false. And that should be the code for this problem. This problem is a great demonstration of the algorithm binary search as well as simulation. If you learned something from this problem, please make sure to subscribe and like. And if you still have any confusions, please leave a comment in the comment section down below. And I'll see you in the next USACO problem.